Hi, welcome to the fourth section in this course. In this section, we're going to introduce streams that are probably the most exciting new feature of Java 8 and 9. So this section is divided into 4 videos. In the first video, we will introduce streams and compare them to collections and iterators. In the second videos, I'm going to show you a couple of ways to create a stream. Next, in the third video, we're going to explain the notion of lazy evaluation. And finally, in the fourth video, we're going to relate streams to a well-known functional programming abstraction, which is called monad. So let's start with this first video, in which we will compare streams to collections and iterators. In this video, we will introduce streams, which represent a new powerful framework for sequential data processing. We will compare streams with collections and with iterators. Then you will see your first complete example of a stream pipeline. And finally, we will discuss different types of streams. So, what is a stream? In a few words, a stream is a sequence of objects supporting a special type of iteration called internal iteration. Before we talk about internal iteration, let's recall the main features of other standard representations for sequences of objects. So first there's lists, then there's also iterators, and finally the new concept of streams. So what can you do on a list? Where you can add objects, remove objects, you can search for an object, and you can scan or iterate. So how do you iterate on a list? Well, you're supposed to use an iterator. And the iterator has very limited functionality, which is basically iterate, which means give me the next object in the sequence, and possibly remove the last object which was returned. Now stream, on the other hand, from some abstract point of view, they only have one special operation, which is internal operation. And in a few words, internal iteration means apply some operation on every object of the sequence. So this may seem like a single operation, but in fact, since you can apply a wide variety of different operations on the elements, you get a wide set of practical operations. Now, in order to understand internal iteration, let's start with a very simple example. Suppose we want to print every element in a sequence of objects. In the first case, our sequence of objects is represented by a list. Just a simple list of integers. So how do we print every integer in the list? Well, we can use an enhanced for loop and print every integer n in the list. Next, suppose our sequence is encoded as an iterator. Well, we can use a while loop in a standard way to get every integer in the sequence and print it. Finally, let's move to streams. So this is the first time we see this stream type. It's actually an interface, and we'll see in a few minutes how you can instantiate and populate such a sequence. For the moment, let's just have a look at how you print every object in the sequence. It's quite different from the previous two cases in that there is no loop which is visible here. Instead, we call the forEach method of the stream object, and we pass, in this case, you recognize the new syntax of a method reference. So we're passing a reference to the printline method of the system.out object. So as you can see, there's no loop, no explicit loop here, and there's no variable referring to the generic element in the sequence. And this is the key idea of internal iteration, which is you pass some functional object to the for each method, and the for each method takes care of the iteration. So it's internal because the responsibility for the iteration lies within the collection, or in this case lies within the stream. So this is all based on this interface called Stream. It's in the java.util package. It's a parametric interface with more than 30 instance methods and a couple of static methods. And in the following sections, we're going to explore a good number of these. So let's summarize what internal iteration is. It consists in repeatedly applying some operations to all elements in a sequence, and to do so in a way that shifts responsibility from the client to the stream library. That's why it's called internal. Now, what kind of operations can be applied to the elements of a stream? Well, three kinds of operations. First, there's a special kind of operation, which is build operation. This is an operation that creates a stream from some data source. Next, there's intermediate operations. They convert one stream into another, and possibly into a stream of another type. Finally, there's terminal operation. They convert a stream into something else, or maybe nothing, meaning that there's terminal operations that return void because they have some other side effect. So rather than returning a value, they change the state of something else. Now, these operations are supposed to be chained in this particular order. So a sequence of operations, which is called a pipeline, must start with a build operation, then it must continue with 0 or more intermediate operations, and finally it must end with exactly one terminal operation. And this terminal operation may or may not return a result. Okay, so as a quick preview, let's consider our first example of stream processing. And we're going to use our standard employee class. This is a class characterized by name, a string name, and an integer salary. And suppose we want to print the names of the employees whose salary is at least $2,500, and we want these names to appear alphabetically sorted, starting from some collection of employees. Let's say just a simple array of employees. Take a few seconds to imagine the standard imperative implementation using collections and loops. It's clearly quite simple. We're going to need a loop, an if then else to check the salary. Then we're probably going to put the selected names into a temporary collection of strings, and then we're going to sort this collection before we can print the names alphabetically. So it's simple, but it's not going to look particularly pretty. On the other hand, that's how we do it with streams. So suppose you have an array of employees. What we do is we convert the array into a stream with the static method of the arrays class. Next, we apply the following 4 operations. Filter in order to select the employees with a high salary. Map in order to extract the names of the selected employees. Sorted is going to sort these names. And finally, the for each method that we have already seen is going to print out these strings. And in terms of types of different operations, we have that the stream method is a build operation. Filter, map, and sorted are intermediate operations, and for each is a terminal operation. And in this case, notice that the for each operation returns void. But as a side effect, it prints, in this case, it prints the strings. Finally, you should be aware that streams come with a couple of options. The main options are the following. A stream can be ordered or unordered, and it can be sequential or parallel. Let's see what these mean. First, what do we mean by ordered? Well, the objects in a stream may come in a fixed order or not. If they do, this order is called the encounter order because it's the order in which the objects will be encountered along the stream. And if you're dealing with an ordered stream, the operations that you perform on it are going to be executed according to the encounter order. On the other hand, if you're dealing with an unordered stream, operations may be performed in any order, meaning there's no specific guarantee on the order in which they're going to be executed. Next, if you have a sequential stream, the operations are going to be performed on one object at a time. Conversely, with a parallel stream, operations may be performed on several objects in parallel. And as we will see, this is really one of the strongest points of streams. That is seamless parallelization. Very simple way to achieve parallel executions. So summarizing what we've seen in this video is that streams are a powerful new way to process that data sequences, and their basic operation is called internal iteration.